offend anyone with this statement, but our topic today is not the most riveting of topics we will discuss in chemistry. It is significant figures, and let's do it. The purpose of reporting quantities using the appropriate number of significant figures is to accurately report meaningful measurements. It is not to torture you. There's a reason for it. For instance, let's use something that you have experience measuring. So let's do just a real quick speed calculation. Speed as opposed to velocity, because I'm not going to put a direction here. Alright, so I'm going to use a meter stick to measure my distance. And my meter stick can measure millimeters. So let's say the distance I traveled was 51.2 centimeters. Okay, this is as accurate as I can get. Alright, and then the amount of time it took me, I'm going to use a stopwatch, and let's just say my stopwatch could read to the hundredths. So let's say it's, I'm going to travel this distance in 4.76 seconds. Okay, and I want to calculate the speed. So let's do this here. 51.2 divided by 4.76. Okay, let's try this again. 51.2 divided by 4.76. Hopefully I'm not going to get a whole number. Oh good, I don't. I get 10.75630252, according to my calculator, centimeters per second. So why can't I report that? Why can't I write this as my answer? Do I have a measuring instrument that can measure to this degree? No. I got this thing right here, right? It can go to the 10th. This can go to the 100th. And so I can't give an answer like this because neither one of my measuring instruments can measure like that. And so really, you guys, significant figures is more like the rules for rounding. How do I know what kind of number I can report from a calculated value? Alright, because what we have to keep in mind is that we are in science. This isn't pure math. The numbers that you're given in problems are measurements. And we cannot report an answer that has way more digits than any of our measuring instruments can measure. It's invalid. Okay, so when we are reporting a calculated quantity, significant figures are going to be based on the quantity or measurement. We're in science. The measurement with the least number of significant figures, because that's the best our measuring instruments can do. Alright, so let's look at these things. So number one, non-zero integers are always counted as significant, are always counted as significant. Integers other than 0. All right, now for zeros, there are three kinds. So zeros. Okay, there are three types of zeros. There is the leading zero. Leading zeros are not significant. Leading zeros are not significant. They're placeholders, is what they are. So, for instance, 0.00225. How many significant figures does this thing have? It's only got 1, 2, because these zeros are leading zeros. They are in the front. They're placeholders. That's all they are. So this number right here has 2 sig figs. Okay? It's the non-zero integers. Captive zeros. Are significant. So for instance, 1.008. How many significant figures are here? Well, I got my integers and I've got my captive zeros. How do I know they're captive? They are in between two integers. So they are significant. So this number has got 4 sig figs. And then last but not least, we have the trailing zero. Are not significant unless there is a decimal point. Okay, so the decimal is our key that things are exact, that we've measured it exact. So 100. Notice I've got 2 trailing zeros. They're at the end of the number. Okay, there is no decimal point in this number. So that means that this thing has only got 1 significant figure, this integer right here. 1 sig fig. Because without the decimal point, we don't know whether or not this is an approximation. It might be an approximate number, not an exact number. So to report an exact number, we use a decimal. So 100 point, right? I've got a decimal point here. That tells me we have measured this number exactly to 100. And so 1, 2, 3, this number's got 3 sig figs. Okay. So now, in calculations, what do we do? For multiplication and division, let's put it that way. Multiplication and division. Use the number, use the quantity with the least number of sig figs to round answer. For addition and subtraction, number with the least decimal places to round answer. Okay, so what do these look like? I thought the bell was going to ring, but I'm going to be okay. I've still got a few more minutes. Okay, multiplication and division, you guys, that's what we're going to use the most. And so, for instance, what are my examples here? I got 4.56 times 1.8. 4.56 times, what did I say here? 1.4. Okay, so we're multiplying. This number has 3 significant figures. This number has 2. So what I'm going to do is I'm going to put this thing in the calculator, or do it by hand, and I'm going to get my full answer. Okay, I'm going to get 6.38. Now the question is, can I leave my answer like this, or do I need to round it to reflect the quantity that has the least number of significant figures? This one's got 3, this one's got 2. That means that I have to use only 2 significant figures in my answer. So I'm not going to leave it as 6.38. I'm going to round this thing to 6.4 to reflect that I can only present 2 significant figures in my answer. Okay, this one we won't use very much, but still, I'm gonna show it to you. Addition and subtraction. So, for instance, I've given myself no room here. So, remember, we're going to use the number that has the least decimal places. So, for my example, I use 12.11, 12.11 plus 18.0 plus 1.013. Okay, I'm going to add these things together, and what I'm going to get, 2, 1, 10, 11, 3, is this answer right here, 31.123. So now what I'm going to do, you guys, I'm going to look for my number that has the least number of decimal places. It's going to be this one right here. It only goes to the 10th. And so I have to round my answer to the 10th to follow the rules of significant figures. So my answer here is going to simply be 31.1. Rules for rounding based on significant figures.